Hi. Now we learn few more things called inside the sets. Or when we are learning sets, there are different types of sets. Okay, many types of sets is there, but we named few things, special things. So it is all our mathematical terms only. So there is nothing that hey we have to do like this. No, sir. Our mathematicians named few special things in a special way that we are learning. So what are they? So So, for example, take since we are on the topic of collection of coins, right? Collection of stamps or collection of coins. Okay, let's take a set of coins. So, can I, if I make a statement like this one, like I have all the collection of coins. So, so I have collection of coins. Sorry, set of coins, right? So we have to use the right words. Coins made of wood. Something weird, right? I have all the coins made of wood. Generally, coins are made of metals like gold coins, silver coins, iron coins, or bronze coins, silver to say steel coins, any coins. So aluminum coins, some kind of a coin, but these are all metals which should be thick. I mean solid. Even if you throw it at anything, so it should not break. So those are coins. Generally, coin is made of some metals. I'm thinking made of wood. Is there any coin such like that? I don't know. To my knowledge, I don't think even early men also didn't do it with the wood. So technically, this is nothing. So it is empty. This set is empty set. So can I? Okay, is it a set? Let's go by the definition of it. So if you go by definition of set, so what it says, well defined, well defined. Yeah, it is well defined. Coins made of wood. I collected all the coins made of wood. My definition is correct, and I have all distinct elements. There are no duplicates. By definition, this is correct. That's the reason we put word set here. So by definition, we have to call it as a set. But since it is empty, we say empty set. So generally empty set, our mathematicians given a different symbol, pi. So this is called pi and we can denote it like this, or else you can denote it like this. No elements in it, including 0. You should not write 0 also. 0 is also an element. So there should be nothing inside it. Just curly braces, curly brackets. This is called empty set. So we also in English, empty, void, null, all means nothing. So these are all synonyms. So this can be called as empty set, void set, null set, all the different names for this one, and we denote it with this one, pi. Okay, so we learned empty set. Let's go to the next one. The next one is universal set. It's another type of thing. So no need to get confused. We have given special names to few special things. We already learned it. When it is empty, we learned empty set, void set, and how we did not also. Now we learn universal set. So we were taking the example of or to say stamp set, right? So why I'm telling stamp, not stamp collection, you might already. So I removed duplicates from it. So it became a stamp set. I got a stamp set. So this is my stamp set. So I'll denote with S. I have 1, 2, 3, 4, 5, and a 6. This is my stamp set. So my friend Rakesh has, Rakesh has everything, right? So let's take, this is Rajesh. So Rajesh also starts with R. He got only 7 and 8 stamps. But what about Indian Postal Department? Indian Postal Department. So this is like, okay, who prints everything and they have all the collection, right? So they act like a universal set because they have everything. If you name any stamp printed and used in India, that is printed by Indian Postal Department only. So we can consider, I don't know exactly, but just assume like that for mathematical things. So Indian Postal Department must be having all the stamps. So they act like a universal set because they distribute stamps to everybody. If I go to postal office and buy some stamps, means at least they will be having one stamp. They keep it for reference. So universal set, we denote it with mu. Mu. All these are, I think, Latin letters we pick. Okay, so I don't know why they chose mu for this one, but they chose mu. Mu is a universal set. Universal set means that has all the stamps. Maybe like, okay, stamps held by Indian Postal Department. Yeah, this is my, how to say, set builder form I'm writing. Indian Postal Department. So just I'm using all this Indian Postal Department, everything for understanding purposes. Okay, don't challenge me with, okay, Indian Postal Department formed in 19 something, not at the freedom time. No, just understand that. Think about Indian Postal Department has every stamp because they printed it and they hold that one. So I'm thinking that, okay, mu could be Indian Postal Department, all the stamps held by the Indian Postal Department. Okay, so in that case, this is a mu. Everybody like, okay, so we go to post office and collected, I collected 6, Rajesh collected only 2, like that. So this is called universal set. So like, okay, mu could be all stars in galaxy, stars in Milky Way galaxy. So this is our mu. If you take this as mu, all our solar system, everything will be part of this universal set. So all stars in Milky Way galaxy, if you consider this as a universal set, and all our solar system and there are many other stars which are in Milky Way, all will be there in this mu. Okay, these are called universal sets. Next one is subset. The name itself has that meaning, sub. So empty set has its, or to say empty, the word itself denotes it is empty. Subset, universal. Universal means generally we consider whole thing. The one that has everything is called universal. Sub, the name itself is subordinate. So in English, sub is smaller. Subordinate, I don't know other words with sub. Okay, subway and all these things. Subway is also a restaurant chain, but I'm talking about a subway, bypass things. Subset. So a set and a small set. Subset. Subordinate. If set is a super one, big one, then sub means small set. So when we say a set is a subset, So for example, this is my collection. I have a collection of 6 stamps, as you know. 1, 2, 3, 4, 5, 6. I have 6 stamps. And my friend uh, Ranga. So the Ranga also starts with R. So he has 2 and a 3. He collected only 2 stamps. So his every element. So here I can say stamp or element because the objects inside a set are called elements. Here the element 2 and element 3 which are present here also. So I can say that R is a subset of yes. So how we call it as subset. This denotation, this special symbol. Mathematics is all about symbols. So learn the symbols rather writing the words like R is a subset of. Yes, instead of writing this big sentence, we write. Don't make it like a C. It's like this one. Okay. R is subset of S. When we say this one, every element in R should present in S. So what it means? Every element in R is there in S. Then we will write like this. Look at this one. Every element 2 is there, 3 is there. R. Can we write S subset of R? What it means? Every element is in S should be there in R. If I pick 1, not there. 2 is there, 3 is there, 4 is not there, 5 is not there, 6 is not there. So we can't write this one because every element is in S, not there in R. But we can write this one. Every element in R, there in S. So R is subset of S. That's what this is how we denote, this is how we read, and this is a symbol and sub set. Thank you. Yeah, there are two other things that we can learn. So if we take this yes, so these are my stamps 1 2 3 4 5 6, and this is Ranga stamps 2 3. So we know that empty set, that is this one, or we can denote pi. So can I say empty set is a subset of this one? So far, can this statement is true? Empty set is subset. Empty set has nothing. So this got nothing. So we can say that okay, there is a nothing element in this one. So empty set is always a subset of any set. So if I take set S, so empty set is always subset of S, and empty set is always subset of R2. Even though it has 2 elements, empty set is always subset of elements with 2 and 3. We can say like this. That's this one. And there is one other statement. Every subset is subset of itself. So what it means exactly? So can I say that is nothing but S subset of S, R subset of R. Every set is subset of its own set. So every element in S should present in S. The statement itself is true, right? Every element in S should be there in S. If I pick 1, it will be there in 1. 2, it is there in S. 3. So the statement itself, you can think twice. It makes sense. So we write these things. So empty set is a subset of any set, and every set is a subset of its own. Thank you.